So now in this video we will study the second part of the chapter number 14, chemical kinetics, that we have to find out the rate law given in the list of conditions that are initial rates, calculate the rate constant given reaction data, determine the reaction order given a rate law data, and determine the unit of the rate constant. So as we have seen in the previous slides and videos, that concentration greatly affect on the reaction rate. So one can gain information about the rate of a reaction by seeing how the rate changes with the change in the concentration of reactant. So if we are changing the concentration of the reactant, we can get some information how the rate is of reaction is affecting. So here we will see one example, that in this reaction where ammonium ion is reacting with nitrate ion and producing nitrogen gas and two water molecules. So this experiment or this reaction was carried out by 6 times. You can see in this table, where experiment number 1, 2, 3, 4, 5, 6, initial concentration of ammonium ion, these are the initial concentration of nitrate ion are given, and then this is the rate. So observed initial rate of the reaction, right? So these are the raw data of a reaction of ammonium and nitrate ion in water. So if you notice this condition number 1 and 2, let's look at condition number 1 and 2, where that you can see the nitrate ion concentration is constant. So these two are constant, 0.2, 0.2, but here we are increasing the concentration of ammonium ion by 2 times, 0.01 to 0.02. Then what will happen, the reaction rate, 5.4 times 10 raised to minus 7 and 10 raised power 8. So this is 10 raised power 8 times 10 raised power minus 7. So if we are keeping constant one reactant, nitrate ion, and just increase the double of ammonium ion, reaction rate also increases 2 times, right? So these are the thing which you get information from the reaction conditions. Let's see another one example where we can keep constant the ammonium ion concentration is constant from last 3 experiment, and here they are increasing the concentration of nitrate ion. So let's consider experiment number 4 and 5. In case of 4 and 5, ammonium ion concentration is constant, but nitrate ion concentration is just double. So if nitrate ion concentration is double, and you can notice the rate of the reaction is 10.8 times 10 raised to minus 7 to 21.6 times 10 raised to minus 7. So this also increases double, 2x time. So we can see that if we compare experiment number 1 and 2, we see that when ammonium ion doubles, the initial rate double, initial reaction rate double, and the same way likewise when we compare experiment number 5 and 6. So here I compare so far 4 and 5. And 6, either you can compare 4, 5 or 5, 6, both will give you same result. So let's compare 5 and 6, where the ammonium ion concentration is constant and initial concentration of nitrate ion is double, right? So here you can see this is 0.404 and this is 0.0 808. So both in this cases, either you compare 4 5 or 5 6. In both cases, once you are increasing the concentration of nitrate ion, reaction rate is also increases 2 times, right? So likewise, when we compare experiment number 5 and 6, we see that when nitrate ion doubles, the initial they double. So from these experiment, we can say that rate of this reaction is directly proportional or have a direct relationship with the ammonium ion concentration, molarity of ammonium ion concentration, and rate also have direct relationship with the nitrate ion. Since rate is depend on both the concentration, so we can combine these two together. So we can combine these two together and we can write that rate is have a direct relationship with ammonium ion as well as nitrate ion. And when we will remove this proportional sign, we place equal sign and then place 1 k, that is constant k, and then we can write a new equation where it is equal to k ammonium ion and nitrate ion, which then written as an equation become this one. This equation is called rate law and k is called rate constant. So this is the rate law equation which we derive from the experimental conditions, that if you will increase one reactant concentration, how the rate will affect, and if you will increase the another reactant concentration, how the rate will affect. Remaining reactant concentration we have to keep constant. So what is the rate law? The rate law shows that the relationship between the reaction rate and the concentration of the reactants. The exponent tell the order of the reaction. This is the new word came, order of the reaction. Order of the reaction is equal to the exponent with the respect to each reactant. Since the rate law is this one, for the previous reaction, rate is equal to k ammonium ion concentration and nitrate ion concentration. Exponent they are talking about here the power. So in both cases power is 1, ammonium ion power 1, ammonium nitrate ion power 1, that is why it's first order reaction. So the reaction is first order in ammonium ion concentration and first order in nitrate ion concentration. So we can say from here that the overall reaction order can be found by adding the exponent of the reactions in the rate law. So if you will add these two reaction order, which is first order for the ammonium ion and first order for the nitrate ion, if you will add these two together, overall reaction order is 1 plus 1 2 or second order reaction, right? So we can generalize the rate law reaction if we have a many reactant number 1, reactant number 2, reactant number 3, 4, 5, 6, and these are the exponent small m, small n. This is important that when we see this type of reaction, these exponent or coefficient must be calculated from the experimental condition, not from the balance reaction. So in that case, rate of the reaction will be k reactant 1, exponent for this reactant 1 will be small m, which is power of the reactant 1. Reactant 2 exponent will be small n, and likewise. Where k is the rate constant, lowercase k experimental unit vary depend on the order of the reaction. Small m and n are exponents. Partial reaction orders small whole number experimental, right? So Next is small n and m. If we will add all these, so this will give the total order of the reaction, overall reaction order. In that case, we have to add all these reactant. Let's see one example. So in case of rate law example, if we have this kind of reaction A plus B equal to C, where rate is equal to K, A concentration and B concentration square. So what is the partial order with respect to A? Suppose this is the experimentally calculated rate law, where A have power, if nothing is written it means 1, right? If nothing is written it is 1. So what is the partial order with respect to A? It will be first order reaction with respect to A, because exponent is 1. What is the order with respect to B? It would be second order, because it is power have 2. So this will be second order. What is the overall order? So for overall order we have to calculate or add all these exponent, third order. So overall order will be third order of reaction. What happen if the reaction, if rate of A is triple? So right now rate 1 is equal to, I can say that K and A is like this one, and if we double rate number 2 will be K, and they are saying what will happen if the rate to the rate if A is triple. So let's do this. This will become 3A. So in that case K will be cancelled, A will be cancelled, only 3 times. So the rate 2 will become 3 times of rate 1. Rate 2 will become 3 times of rate 1. So it will increase 3 times of initial rate. What will happen if the B rate is triple? So let's calculate. Rate 1 K and B will be like square. I'm not including A right now, just including B, because we have to find out the relationship between A rate and B. In case of rate 2, they are saying if we triple this one, so K 3B square. So here K will be cancelled out. What will happen? This will become B square if you will open the parenthesis, and this will become 3 multiplied by 3, 9, and B square. So B square will also cancel. So rate 2 will become 9 times of rate A, right? So what will happen if the rate if the concentration A for A, because A is the first order, so rate will also increases the same order, same way. And in case of if B is the second order, then the rate will become as a power of the many time you will increase the concentration. So this was about the rate law and how to calculate the rate law questions. So whenever we have to write a rate law, we have to always find out the experimental conditions. What are the experimental conditions? From there we can get the information about the rate law. So in next we will see about some more detail in the rate law.